Okay, so we're now going to start diving into what I consider to be the heart of the course, which is we're going to start learning about functions and different types of functions and their graphs and transformation properties. Eventually we'll get to logarithms as well. The first set of videos that you've been watching, there was some review, hopefully, but it was a lot of just some basic review of algebra and some solving techniques with equations and inequalities. Now, like most of mathematics, the stuff that we learned in the previous videos is going to be used throughout the course, because you've probably already aware mathematics kind of builds on itself. Some of the things we learned we're going to be using in later portions of the course. So let's go ahead and start. This is something many of you are probably familiar with, this first section here, or first video. This is linear equations in two variables. And we have, of course, several different forms we could write these in. The one that you're probably, one of the ones you might be the most familiar with is the slope-intercept form. And of course, linear equations just means if you were to graph them, they're straight lines. And the slope-intercept form is y equals mx plus b. And then, of course, we know if we're plotting, this would be like an x comma y as the point that we plot. And of course, these are what are called our variables. These are not things, these would be present in an actual problem. And furthermore, what we often will have here is that x is referred to as the independent variable. And I'm going to emphasize it's not just x, because it could be a different letter instead. It's whatever is, if you're thinking about a graph, whatever you're plotting on the horizontal axis is what's considered to be the independent variable. And y is the dependent variable. And again, just so that if we don't have the variable y here, this is basically whatever is being plotted on the vertical axis is considered your dependent variable. And the reason is that, well, just think about when you would plot these. You would pick a value for x, several values for x, and then compute values for y. And so y depends on the value of x, and x was independent. We just basically picked some values for x in order to plot these. Okay, so along inside this as well, we have two other parameters. One is m, which I'm suspecting many of you are familiar with. This is the slope of my line. And I like to think of slope as rise over run. Or, better yet, I like to think of it as the change in y over the change in x. And just to kind of quickly go through some examples of this, we'll write some slopes down and interpret what they mean here. Now, of course, there will be ways to compute slope, and some of you already know those probably, but we'll get to those a little bit later on in this video. So let's say we have a slope m is equal to 3 over 5. So because these are both positive, you want to think of it as if y goes up 3, x goes up, I'll put in parentheses, because really what we want to think about it is it goes to the right by 5. And that's the whole rise over run. Now, another thing that you can use on these, and sometimes people get mixed up here, if you have m is equal to 3 over 5, you can also write this as, and it seems a little weird to do it this way, but it gives you another way to interpret it, as negative 3 over negative 5, because we know if we divide two negative numbers, it's positive. And all this does is give us another way to use the slope in order to plot some of these graphs, which we'll look at in a little bit here. And what this would mean is that if y goes down 3, x goes down, because of the negative, which with that on the x-axis, that would mean it's going to the left. by 5. And to look at one more slope just to make sure we understand this concept of change in y over change in x. So we get m is equal to -2, which we can write two ways. We could write this as 2 over -1, or we could write this as -2 over 1. And the reason you can write it two ways is the same reason we could write the original one two ways. Now, there's basically two different interpretations. You'll get the same graph, but if we look at this first one here, this would say if y goes up 2, x goes down, which again means we're going to the left by 1. And then the second one there would be if y goes down 2, then x goes up to the right by 1. And so the slope here really positive or negative. If it's positive, if the value is positive, it means you would go up for that. And then if it's negative, you're going down or to the left or for that. All right, so we have one other parameter in these slope-intercept form, and that's the parameter b. And b, as some of you might be aware of, this just gives us the y-intercept. And if the point would be 0, because for a y-intercept x is 0, 0, comma, b. Now before we look at a graph of linear equations, there is, and I'm going to put in yet another color here, I like colors sometimes, there is a special type of equation that has a graph, and these are vertical lines. Vertical lines, well, they're vertical, of course, and they're going through the point A0, and the equation for a vertical line would just be x equals a. Now, I will also highlight out horizontal lines, although technically horizontal lines fall under our slope-intercept form. So a horizontal line, of course, is horizontal, and the equation is y equals b, and it's a horizontal line. Going through the y-intercept of b. So this would be 0, b. Now, I want to emphasize here, vertical lines have undefined slope. You don't want to say they have no slope, they have undefined slope. And the reason you don't want to say no slope, because no slope, do you mean 0 or do you mean that it's undefined? And so that no slope is kind of an ambiguous terminology there, so we don't want to use that. We want to say that it's either undefined slope, or for horizontal line, we have a slope of 0. And that's actually pretty easy to see, because we could write y equals b as y equals 0 times x plus b. It'd be a little silly to write it that way, because we know 0 times x is just going to be 0, but this is in slope-intercept form, and then we can see that my slope here would be 0. All right, so let's look at an example here where we're going to sketch a graph of this. So, using slope and y-intercept, sketch a graph of y equals 2x plus 1. Okay, so let's see here. Get a little graph here for us right now. Try and center it. That's close enough. It's not exactly on my graph paper there, but close enough. Okay, so what is here? Well, first off, we have that m is equal to 2, which is the same thing as 2 over 1. Or, if you want to think about it, it's negative 2 over negative 1. Not necessary to think about it in the negatives, but that is one thing we can do. And then we have, of course, b equals 1, which means my y-intercept is 0, 1. So I'll plot my y-intercept there, 0, 1, and then I use my slope. So using my slope, one of the things it says I could go up 2, because it's change in y over the change in x, so up 1, 2, and then over 1. So there'd be another point right here. And then when you're doing these linear equations, you really want to have at least 3 points here. So I could do another one, start from here going up 2, 1, 2, and then over 1, and that would put a point right here. Now, I just want to emphasize now, when I wrote this negative 2 over negative 1, what we could do instead of going up, and sometimes you want to do this because it's just hard to get all 3 points if you just always use the slope in one direction, is I could go down 2 and to the left 1. So down 2, 1, 2, and to the left 1. And we can see that these are all going to line up in a straight line here. I'm going to do my best without having a ruler to draw a straight line through those. Not great, but you get the idea here. So we draw a line through those points, and if you have a straight edge or something, that's going to be beneficial. And then we have the graph of that equation. So let's look at one more quick example. Let's look at the equation 4x plus y equals 5. Now, I'm doing this one not because it's difficult, but because it's not in slope-intercept form right now. That's not a big deal. We can easily put it in slope-intercept form by subtracting 4x from both sides. So you'd have y is equal to negative 4x plus 5. And then, of course, we can see that my slope here would be negative 4, which is negative 4 over 1. I won't write it the other way. We should be comfortable now with the fact that negative 4 means I could go down 4 and to the right 1, or it means I could go up 4 and to the left 1. Alright, and then we also have b, which is 5, so my y-intercept is 0, 5. So let's get a graph on here. And so we'll go ahead and plot the y-intercept here. So I'm going to go ahead and, because of my y-intercept and slope, I'm going to go ahead and make the scales different on the y-axis. And so you can do this, you just have to make sure to label your axes here. And so what I'm going to do, just putting some tick marks in, and on the x-axis, I'm still going to have this be 1, 2, 3, 4, negative 1, negative 2, so on. But then on the y-axis, I'm going to go by 2's. 2, 4, 6, 8, 10, and then I'd have negative 2, negative 4, so on. The only reason I'm doing that is it will give me a little bit more room to graph this here as far as not needing as much space on the screen here. Okay, so let's first plot my y-intercept, which is 5. So 4 and 6, so that's literally going to be halfway between 4 and 6, so it's right there. And then I'm going to use my slope here. So my slope is negative 4 over 1, so I'm going to go down 4. So down 1, 2, 3, 4, and then over 1. So there's a point right there. Then I'm going to go down 4 because I need 3 points. So 1, 2, 3, 4, and then over 1. So there's a point right there. And then again, we at this point just draw a straight line through those points, and the arrows, of course, indicating it goes on forever in both directions. And that, of course, is then my graph of the equation. Now, before we move on to calculating slope here, slope does tell us some very important things here. If m is greater than 0, as in the first problem, the key thing to notice here is that the graph goes up from left to right. In other words, which we'll talk about this in more detail in another section, it means that we're increasing. We're going to talk about increasing and decreasing in more detail in another video. If m is less than 0, the graph goes down from left to right. And again, we'll talk about this in another video in more detail, but that would mean it's decreasing. If m equals 0, we have a horizontal line. Which, again, kind of talking about something we'll talk about later, this means it's constant. And then the other one, which we'll talk about in this section, but we don't have a term for it. And the reason we don't have a term for it is when we talk about functions, this case is actually not a function. If m is undefined, we have a vertical line. Okay. So the last thing I want to cover in this first video on linear equations is, of course, computing slope. Now, as I said, many of you are probably familiar with this, but let's go ahead and go over it again. So slope, remember, is the change in y over the change in x. Now, I'm going to write another notation down here, just to get you familiar with some other notation that's used in other math classes. Sometimes you'll see this as delta y over delta x. And delta, really, in mathematics, it's often used just to mean change in. So delta x being the change in x, delta y being the change in y. So let's actually talk about how we would compute slope. Now, to compute slope, we need 2 points. So given 2 points, x1, y1, and x2, y2, the slope of the line passing through the points is m equals y2 minus y1 over x2 minus x1. Now, one thing I want to point out is y2 minus y1, that's just the change in y, x2 minus x1, just the change in x. But what's very important here is notice that you have y2 and then an x2 beneath it. The order here does matter, and it matters because, of course, we're doing subtraction. Order of subtraction matters. So let's look at a couple quick examples here to wrap up. So find the slope of the line passing through the points -5, 6, and 2, 8. Now, it's not necessary to label them like this, but I'm going to go ahead and do it on this first example here. So I'm going to go ahead and label x1, y1. It's not a bad habit to get into, but it's not necessary to. x2, y2. Now again, just like if you don't have the formula for slope memorized at this point, you should write it down every time you use it. M is equal to y2 minus y1 over x2 minus x1. Alright, now we're just going to go ahead and plug in those numbers. So you have m is equal to y2 is 8 minus 6 over 2 minus negative 5. So 8 minus 6 is, of course, 2. 2 minus negative 5 is 7. So my slope is 2 over 7. Now, one thing I want to point out, it doesn't matter which point is point 1 and which point is point 2 as long as you keep things consistent. And to illustrate that, let's just redo this one real quickly, but label in blue 2, 8 being x1 and y1 and negative 5, 6 being x2 and y2. So in this case, my slope would be y2, which is 6, minus 8 over negative 5 minus 2. Well, 6 minus 8 is negative 2. Negative 5 minus 2 is negative 7. Of course, dividing two negative numbers gives us positive, so you get 2 over 7. And we get the same answer, which really shouldn't be surprising, but I like to always point out that you can do the point in any order. Alright, so let's look at a couple more examples here real quickly. Let's look at 0, 0, and 0, negative 6. Now I'm not going to keep writing the slope formula down, but we'll go ahead and do these computations. So this would be m is equal to y2, negative 6, minus y1, 0, over x2 minus x1, which would be 0 minus 0, which gets me negative 6 over 0, which hopefully we all recognize right away. This is a problem because you can't divide by 0, so this is equal to undefined. Remember, we say that this is an undefined slope, so my slope m is undefined, which we also know that means that this is a vertical line that we're going to have drawn here. Let's look at one more example here, just to wrap things up. And for some reason, the reason I want to go over this, for some reason these two that last example sometimes trouble people when they see them on some homework problems. So you have 0, negative 1, and 3, negative 1. So I'll go ahead and label these here, x1, y1, and x2, y2. So if we compute the slope here, we would have negative 1 minus negative 1 over 3 minus 0. Negative 1 plus 1 then is what I'd have, so that's 0 over 3. Now, for some reason people mix up this previous one and this one. 0 over 3 is absolutely fine. 0 divided by 3 is something you can compute, and 0 divided by 3 is of course just 0. So that means we have a horizontal line because we have 0 slope. Alright, I could do some more examples, but it's really just, equation plug and chug. Most common mistake I see people making on these types of problems is just arithmetic errors. So the next video we'll talk some more about linear equations and actually how to find an equation given some information.